Non-linearity. How do we handle non-linearity? Yeah. If we, let's say, are trying to build a model that predicts sales, how much sales or revenue we will generate based on ad spend, how much money we spend on advertisement, and we realize that we have this linear model which we are able to fit with OLS, and we see that it is not able to really predict a lot of these data points with a positive residual and many more of these negative residuals and again more of positive residuals. If we start to see a pattern where these error residuals are not really uniformly distributed above and below our predicted model, which is in this case ordinary least squared, then we need to pause. We need to figure out how to handle this errors that are not linear, and we're trying to fit linear relationship here, right? So what we need to do is we need to pause and then transform our input variables. It could be that you transform your independent variable here, ad spend. Or in this example, what I have done is I've kept ad spend as is, but I've transformed sales from sales to log of sales, meaning I'm using ad spend to predict log of sales. Yeah. In that case, what I realized is, hey, I now have a linear relationship which looks much better. My OLS line that I'm able to fit, I see errors that are uniformly, distributed. And if I do a residual analysis like I did here, I see that there is a constant band, like above the zero and below the zero line. I see errors that are, I don't see a pattern except that they are equally distributed above and below in the same, and they don't like increase over time, or I don't see heteroscedasticity. So when you see that there is a clear band and you're able to handle the non-linearity by this transformation, then your model R squared also is going to be better in that case, and you will see that the model better fits and explains the variation. And so if you have better R squared, the model has less variation than a simple model around the mean. So you will handle non-linearity in so many ways. You could have, in this case I did log transform of sales. You could do a log transform of ad spend and then find out if you can predict sales from it. Or you do log transform of ad spend to predict log transform of sales. And then you will find out which is a better R square. Where is there an error pattern with the residual plots where you don't see a major pattern being built, and you have errors being distributed equally above and below the zero line. Yeah. So in this case, we see positive residuals, and that would be these data points, and then negative residuals would be these data points. So negative error, positive error, right? And so like we did log transform to handle non-linearity, you could do polynomial transform. You could do square root. You could do various other mechanisms to transform your input data so that you actually can then fit a linear relationship. Your data points need to exhibit some sort of a linear relationship for you to fit a linear model. And that's what we do by handling non-linearity, by transforming our data points so that we can actually fit a non-linear relationship into a linear relationship. Yeah. So by transforming this model. But now that we've transformed this model and we are predicting log sales, then we need to be very careful, as to how we interpret log sales, because at some point we want to predict sales, not log sales. But a model will predict log sales. Yeah. So to quickly recap, these are the three steps. We first build a model using OLS. We've covered that in the previous video. In this case, let's say in the previous we were able to predict from ad spend sales. Yeah. We have the model, the model R squared, and let's say this was like 0.6. Yeah. So and then model parameters gives us the intercept, and also gives us the prefix for ad spend. So given ad spend with this intercept, we can then model and predict the sales. Yeah. So sales equals intercept plus ad spend prefix times the ad spend input variable. So now we can predict. So using the model, we can predict. That's step 2. and then we can plot their residual scatter plot and then actually see what it looks like. So let's say it was this setup is what we saw. So what we did is we did a log transform. So we added a new column. You can add a new column. You initially had sales column, you had ad spend column, you add a new column which says, which you can call it log sales, and then you could do the log of the column that was sales to get log sales. Now you would have three columns: sales, ad spend, and log sales. So now you can do OLS saying, hey, I want to predict log sales given ad spend. Yeah? So then the new model will be built, and let's say the new model is like much better, right? And you start to see that there's a uniformness in terms of errors above and below the zero line. And we now have a better model, and we are able to handle nonlinearity through, in this specific example, using a log transform. But you could also do a polynomial transform, right? You could predict log sales based on ad spend squared, right? So you could do like create another column which is ad spend squared, and then try to see what that looks like. So you would have to experiment with what is actually a linear relationship that you're trying to fit, yeah? And you check model R squared to see whether it's actually reducing the variation than a normal model with a variation around the mean. So if you keep getting better and better R squared, you are on the right track in some sense. But remember one thing, that the model now is able to predict, given ad spend, log sales. So you want to not look at this as sales, but this is log sales. So if you want to convert log sales to sales, you take the exponent and then you transform from log to sales, yeah, log sales to sales. Similarly, if you had sales squared being predicted, then you want to square root of sales to actually go back from what you transformed to the original variable. Yeah, in this case, I've taken a specific example of log transform being undone here. But whatever you transform, if you transform both your input variables, then be sure to specify in your model the log version of your ad spend, and you get the log output, so then you want to transform that back again. So these are some techniques in which we can handle non-linearity and actually fit a linear model. But these steps are needed for us to handle that. Yeah? Residual analysis of errors is super important. Doing plots, scatter plots, and actually looking at like, hey, what did I predict, and what was the actual value, and what is that error, and then plotting them will be really helpful to check the goodness of fit and detect issues that you can fix with transforming your inputs. Thanks.